Hello everybody, we are going to do a freezing curve lab. We've been talking about phase changes in class, so I want us to actually see a phase change and watch what the temperature does during a phase change. So we've got a few things here. I've got a big beaker with some water, and I have a beautiful assistant here named Ashton. She's going to help me with the lab today. I have some salt. I have some water from a bottle, and I've got graduated cylinder, and I've got a test tube, and I've got a thermometer. I'm going to try to show this thermometer to you during the lab. I'm not sure how well you'll be able to read it, but I'm going to try to show you just so you can see what the temperature is. I've got a timer, and I've got a big bucket of ice right here, which I'm going to move out of the way once we get what we need. So what we're going to do is we're going to freeze water. Freezing is a phase change, right? Okay, so we're going to demonstrate what temperature does during a phase change. So we are going to take our water. This is just faucet water, and I'm going to add some ice to it. Get a little bit, get it getting cold. All right, and then set this out of the way. All right, and then I'm going to hopefully get it where you can see it better. All right, and then I'm going to take and add some salt in the ice. Can you pour some salt in the ice for me?
How much?
Just pour right now, and we'll see. I'll tell you when. Keep going. Keep going. That's probably enough, okay? How many of you have ever made homemade ice cream? If you've ever made homemade ice cream, you know that in you've got a big bucket, and then you've got that metal ice cream bucket that you stick in the middle. And on the outside of the metal ice cream bucket, you put lots of ice, but you also have to put rock salt. Does anybody know why you have to put that rock salt? The reason that you put that rock salt is because freezing is 0 degrees Celsius, right? Or 32 degrees Fahrenheit. But if you just get it to 0 degrees Celsius, you're not going to really freeze the ice cream. But when you make a solution, which is something mixed in the water, in this case a salt water solution, and you put that salt in the water, it allows that ice to be a liquid, but to be below freezing, because salt water freezes at a lower temperature than plain water. And so with that salt water in there, it's able to go below 0 and stay a liquid and help you freeze what's in the inside container. So that is the concept we're using with this. All right, Ashton, so we're going to use, our stirrer is nothing fancy. It's a plastic fork. Just stick that in there and mix that salt in. Can you mix that salt in? Woo, not splash me. Let's mix that salt in there. Woo, we're just splashing ice everywhere. Let me see it a minute. Let's get it mixed in there. Okay, so now we have a saltwater solution. Got it all stirred up. And
Wait, can you drink that water?
no, we do not need to drink salt water. That would be nasty, and it would make us dehydrated. So we're gonna leave that to the side for a second. Okay, and now I'm gonna take my graduated cylinder and my bottled water. Now this has just been sitting in my classroom. It has not been in the fridge. It's a little cool, but it's just room temperature. Whatever my room has been today, and that's been a little cool. But we want to measure out. We're gonna start with 5 and see if that will be enough water for our experiment here. Of course, I got it up to about 6. All right. All right, 5.5. We're going with 5.5. Okay. So we're going with 5.5. milliliters in the test tube. That is perfect, okay? All right, so we've got 5.5 milliliters of water in our test tube, and I've got a chart, which this is gonna say heating curve lab. We're not doing the heating curve, we're doing freezing curve, but I just had this chart handy, so I'm using it. You've got a chart right here. I'm gonna set this to the side. Okay, so on this chart, you're gonna see 3 columns. And this will be posted in your Google Docs account. So if you've not seen it, it is posted in Google Docs, and it is there for you to fill in, or you can print out and fill in and go back and fill in digitally later, whatever you prefer. But this is what you're gonna do. You're gonna see this with some questions. All right, so let me show you what you've got. You've got time, temperature, and condition of the water. And so obviously you're not here to see those things or measure those things, so I am going to do that for you. On the time, it's in minutes. You'll see that it's in minutes, and you'll see that it's 0.0, 0.5, 1.0, 1.5. So you're measuring every half minute, which is every 30 seconds that we're taking a temperature. So this is gonna be, once we start, we've gotta stay on top of our time to make sure that we're measuring what we need to measure, okay? So I have a timer here that I'm gonna have to watch. We got a thermometer. Another tip that we need to make sure that we follow in this lab is when we have the test tube and we're taking the temperature of the water, we do not want the thermometer to just sit in the test tube. We don't want the temperature of the glass. We want the temperature of just the water. So we're gonna hold it midway in the water, okay? We're gonna hold it midway in the water and try to keep it from touching the glass, okay? And so I'm just gonna let it sit in there a second just to kind of even out and see what the starting temperature is going to be. And I'm gonna get some of these things out of the way that we don't need. So can you go put this on a desk over there? And go put the salt on a desk over there, because we don't need those anymore. Thank you. And also, you can go put this bottle of water. Clear our area. Okay. Now, your job, Ashton, is going to be the stirrer. Okay? You got to keep everything stirred. Can you do that? Okay. All right. So, we're going to put our ice right here. And I'm going to pull out the test tube when we get started so that you can see the condition of the water and what it looks like. So it may take a little bit longer than normal just because we're going to be pulling the test tube in and out, and I'm going to be showing it on the camera, but that's okay. We should still get the results that we need, okay? So the water should have had time to even out about now. All right, so if I look, and remember, we're taking temperature in degrees Celsius and not in Fahrenheit. So our freezing point that we are looking for is 0 degrees Celsius, which would be 32 degrees Fahrenheit if we were measuring in Fahrenheit. But we're looking at Celsius, so it's 0 degrees Celsius. And just a fun fact, Celsius boiling point is 100 degrees. The boiling point for Fahrenheit is 212 degrees, all right? So let's look at this. I'm going to see if I can show it to you where you can see what the temperature is. So it is right there at about 20, I'd say 22 degrees. I'm going to say 22 degrees Celsius. And so I'm going to come to my chart, and at 0, I'm going to write 22 degrees Celsius. And then my condition of the water is it's clear and it is a liquid. Okay, there's not really much to say about the water. It's clear liquid. All right, so what we're going to do is I'm going to try to hold this where it's suspended in the middle. And Ashton, what I want you to do is when I insert this in the ice, and I try not to splash me again, okay? Let's not splash everywhere, but I just want you to take your fork and I just want you to stir around it, okay? Can you do that? All right. All right, so, and then I've got my timer, and I've got to be really conscientious about my timer because I want to make sure I'm measuring every 30 seconds, okay? All right, so I'm going to put it in. I'm going to start my timer, stir. We're just going to sit here and try to freeze some water. And so we're just stirring to keep that ice moving and try to cool this water that's in the thermometer. I'm gonna try to keep the water that's in the test tube, and I'm gonna try to keep the thermometer suspended inside of it. And so now I'm at 30 seconds, and I am down to 9.5 degrees already. Okay, and it's still going lower. All right, so I'm going to put that back in. Keep stirring, keep stirring. And so I'm going to say 9.5 degrees Celsius. There was a little bit of condensation there from cooling the air above it, but it was still a clear liquid. All right, we're at a minute. So let's look again. We are at 4 degrees Celsius. So we're going down quickly. All right, keep stirring. It's still a clear liquid. Now, ideally, you would have a person to record, a person to store, and a person to hold a thermometer. But I'd say for a kindergartner, she's a pretty good lab partner. All right, we are now at 1.5 minutes. And so we are at 1.5 degrees Celsius. It keeps going lower too, so I'm gonna write that down. It's going down fast. All right, we have 3, 2, 1. We're gonna measure again. And we see we have a clear liquid, and we are down, it says 0 degrees Celsius right now. So we're at 0 degrees Celsius. It's still a clear liquid. We should be at 2 minutes writing things down if you're writing along with me right now. All right, we're 2.5. It looks like we may have some solid pieces starting to form in there, and we are still at 0 degrees Celsius. Okay, I don't know if you can see it or not. We're at 0 degrees Celsius, and there are some solid pieces starting to form in there. So let's get it back in the ice. See some small solid pieces. I took too long to show you that one because I'm fixing to have to take it out again. At 3 minutes, we are at 0 degrees Celsius, okay? So we're gonna keep going. There's still some small solid pieces in there. All right, we're at 3 minutes and 30 seconds, and we're still at 0 degrees Celsius. Again, small solid pieces. Let me get it back in there. Ideally, you don't want to leave it out too long. Keep stirring on. Don't press on the thermometer now. You don't have to stir too much, just enough to keep that ice moving around it. Make sure it's got cold in it. All right, we're at 4 minutes. We're at 0 degrees Celsius.
Why do we keep going at 0 degrees Celsius?
I don't know why we keep going at 0 degrees Celsius. I may have skipped a measurement there. Let's see, maybe we can find out. Maybe that's the whole point of the lab, is to find out why we're still at 0 degrees Celsius. Easy. All right, let's see. We are at
0 degrees Celsius.
0 degrees Celsius, and we still have some solid pieces in there.
Come on, man.
keep stirring. I'm gonna add a little more ice. All right, we're at 5 minutes. We're still at 0 degrees Celsius. Still liquidy, with a few small solid pieces. Now I added some more ice. Why don't you go grab the salt and let's add a little more salt to it, okay? Oh no, turn it this way. Turn it this way. All right, that's good. That's good. You can go put it up now. And I'll mix it in and then continue stirring. Oh, we give her 5 minutes, 30 seconds. We forgot to measure. We're still at 0. 5.5 minutes. Still at 0.
Okay.
Okay.
Wonder why we keep having it at 5 degrees Celsius.
0 degrees Celsius.
I mean 0 degrees Celsius.
Let's see, we're at 6 minutes. We'll see where we're at. We're at 0 degrees Celsius.
I think we should add some more ice.
I think we're full.
We'll just add a little bit more
Let's see if we can move this maybe where they can see it just a little bit better. Now that we've got some of our stuff out of the way. Don't splash it now. All right,
water.
we're at 6:25, so we're fixing to take out and measure again for 6.5 minutes, and we are still at
0 degrees Celsius.
0 degrees Celsius.
Let me see how much we got 0 degrees Celsius.
A bunch. It's here.
Let me see.
It's here a bunch.
What
Well, then I'll
is-
keep stirring while you're looking.
0 degrees Celsius. 0 degrees Celsius. I think it's gonna be 0 degrees Celsius again. Yes.
It's pretty mixed. I don't know if we have to stir much. All right, we're at 7 minutes, so we're gonna look again. Oh,
It's 0 degrees.
I can see some more ice crystals
Let
forming.
me see.
So let's put it back in. We're still at 0 degrees Celsius.
I could write it down for you when you need it.
Okay. Well, the next one's gonna go right here. Let's scoot over a tad bit so you're in the video. All right. Again, at 7.5, we're still at 0 degrees Celsius. Yeah, let's see. We're still at 0. I don't know if you can see that well or not. We're still there. Who knew that freezing water could be so exciting, huh?
Are we?
All right, we're fixing to be at 8 minutes. All right, and we're at 8 minutes, and we are still at 0 degrees Celsius. And look at the very bottom of that. We can get that ice, the water off. We can start to see some ice forming down at the bottom.
Wait, can you kind of wiggle it?
No, I'm not gonna wiggle it. All right, let me write down here, ice forming at the bottom. All right, so the next number is coming up now, and we are at 0 degrees Celsius. And if you look at it, you can feel that there's ice forming. You can see that there's ice
Wait, can I
forming.
feel it? Can I feel it?
It looks like little lines on your screen there.
Wait, can I feel
All right. All right, we're at 9 minutes, and we are still at 0 degrees Celsius. And if you look, I'm not even holding the thermometer up. It's resting on this ice that has formed at the bottom, and it's pretty stuck to it. It's not coming off. So
What?
just waiting on time. All right, it's 9.5 minutes, and we are still at 0 degrees Celsius at 9.5 minutes. Look at her. She's even using her units on her numbers. She's even writing degrees Celsius. Y'all know units are important because you can't have a unit in science without, you can't have a number without a unit in science. You gotta have that unit to tell what you're measuring. All right, we're now at 10 minutes that it has been in the ice, and it is still at 0 degrees Celsius. And we've got more and more ice forming. The thermometer can still wiggle some in the water, but it is not as mobile as it was. I'm videoing. What you need? The Screencast-O-Matic. I uploaded it in the Screencast-O-Matic, and you download that app in, hold on, let me measure. It's 11 minutes. We're at 0. Then you download that app into Schoology.
Okay, I don't know if I downloaded it, you gave me a choice and I uploaded it to Google Drive, but I didn't know,
Well, you could do that.
I don't know if it worked, we'll see.
It's okay. It's okay. All that teacher talk we have to do. All right, that's 11 and a half minutes. So we are now still at 0, and there's more ice. I don't know if you can tell that there's more, but there is more ice there. I cannot wiggle the thermometer side to side. It is now stuck in place. Not only top to bottom stuck in place, but I cannot wiggle it side to side. So we are now at 12 minutes.
0 degrees Celsius.
It is at 0 degrees Celsius.
Wait, I already wrote that down.
I know, write it again at 12 minutes right there.
I think I'm kind of ahead of you.
No, we're right together. See, look, my timer is at 12 minutes and 21 seconds right now.
I think it's going to be 0 degrees Celsius. I know it's going to be 0 degrees
You
Celsius.
know it's going to be 0 degrees Celsius.
Yes.
Oh, no, it's not. It's at a -1 degree.
Please.
Well, it's at -1. See, so if we look, it's below 0 now. It's at -1.
Sorry.
Oh, it's okay. So look, so we're going to write a line in front of the 1, and that means negative. That means it's below 0.
Whoa.
Whoa, it surprised you, huh?
Now we had like 16 0 degrees Celsius.
I know. Let's see. We were at 13 minutes. We're still at -1. So can you write a -1 there for 13? Y'all didn't think it was going to change, did you?
Mm-mm.
She didn't. Did you?
Mhm.
No.
It never changed.
It was 0 for a long time, wasn't it? All right. So we're almost to 13 and a half minutes. And so our temperature now is at -2. -2, and look, it is solid. That thermometer is not moving.
Wait, can I look? Can I feel
Yeah,
it?
it is. It's a solid piece of ice. It's cold, isn't it?
Oh, yeah.
It's cold.
Hey, we're right here.
And look, the thermometer does not move. It is
Wait,
solid.
wait. Is that ice? Right there.
It's just condensation. Let's get it back in.
I got it.
We're almost at 14. Put it at -2. Is it -2?
Wait.
13.5.
And then we...
2. And we're at 14, and we're still at -2.
Still over 2.
-2.
Finally.
And we were solid down here at the -1. We were solid. Actually, the 0 before that, we were all solid. So what happened? The water froze. We went through a phase change. All right. So
Wait.
we're at 14 and a half, and we're at -3 now.
-3. I'm gonna write that down.
Yeah, we were at -3. All right, so now we're at 15 minutes, and we are at
-4.
-4. We
I
are.
knew it.
You knew it. We're at -4 degrees Celsius, and it's all solid. You can see all the lines coming off the thermometer. The thermometer's not moving. It's all solid.
I think it's going to be -5 again.
You think so? Well, we're going to do another minute. We'll go to 16, and then we're going to stop, okay? So we're at 15 and a half now, and we're at -4 again.
16.
We're at -4 again, 15 and a half. And we're going to stop at 16 minutes. I think that's enough time measuring and watching water freeze. All right, last measurement here is going to be -4. We're still at -4.
Yep.
Okay, and I'm going to leave this out. 'Cause now it's got to melt. It's got to go back through another phase change, right? Go backwards. All right, so I'm going to get a cup.
Wait, can I look at that?
Actually, I'm just going to hold this up and let y'all see it because it's going to do something in a minute
Wait, can I
that I
look
want
at
you to see.
I wish you could take
No,
it in.
I wish you could see. Can't really see in there good on the video, but it is solid. Okay.
Wait,
No, don't try to pull it, okay? Because it's frozen in there.
we're going to break the ice.
No, we're not, because we don't want to break the thermometer. We have to be really, really careful.
That
'cause-
thermometer is breakable.
It is. It's glass. It's glass. It's breakable.
Oh.
All right, so let me read through and recap the numbers real quick that you need. At 0, it was 22 degrees Celsius, and it was a clear liquid. At 0.5 minutes, it was 9.5 degrees Celsius. It was starting the air was condensing, and it's still a clear liquid. Then you had at 1 minute, 4 degrees Celsius. At 1.5 minutes, it was 1.5 degrees Celsius. And at 2 minutes, it was 0 degrees Celsius. And it was 0 degrees Celsius all the way down to 12 minutes. Now, when we hit 12 and a half minutes, it hit -1 degree Celsius. And then at 13 minutes, it was -1. At 13.5, it was -2. All right, sit down. At 14 minutes, it was -2. At 14 and a half, it was -3. 15 minutes, it was -4. 15 and a half, it was -4. 16 minutes, it was -4. All right, so, and it started to be a solid, full solid at right around 12 minutes. Some other descriptions to put in there: at 2.5 minutes, we started seeing some small solid pieces. At 8 minutes, we started seeing some ice forming, but it was full solid at 12 minutes. So the whole time that this was happening, what we were doing is we were removing energy from this water that was inside the test tube. Well, how were we removing energy, or what kind of energy? When you think of energy, I want you to think of heat. Okay, so we were removing all the heat that we could from the water in here to make it freeze, to make it go through a phase change. And a phase change is the adding or removing of energy. But oh, we got a sneeze coming. Maybe not. Okay, so we have in this phase change, when it's hitting 0 degrees from 2 minutes all the way to 12 minutes, that's when it's freezing. And it's not going to go any lower than 0 degrees until all of this in this test tube was frozen. Now, once all of it was frozen, then it's going to start.
Wait, this is shaking.
This is shaking now, so that means it's melting up. Proof
What?
that we had ice. That water froze, because that is ice
Wait, can
all
I look?
around
Can I
that
look?
thermometer.
Can I touch it?
Touch it. It's ice.
Ooh, it looks like a popsicle.
Well, it's not a popsicle. We don't put anything in our mouth in the science lab, right? Okay?
Wait, can I?
So you can see that is ice around the thermometer in the shape of a test tube. I'm trying to go to a lot of different angles so that you can see. Okay? So it is melting. In fact, right now it's back at 0 degrees. So it's hitting that phase change from the other end. If you look at that graph that I put on on Google Docs the other day. Okay?
Just looking at it.
I know, but we gotta finish talking about the lab. I'll keep it out. I'm sure everybody else wants to see too. We're gonna have a mess here when this is over. Okay, we don't need that. And you're not doing any of your own experiments right now. No, ma'am. Okay, we're gonna finish this. Okay? All right. So it was at 0 degrees going from 2 minutes all the way down to 12 minutes. And I may repeat myself here. If I do, you're just going to have to deal with me. That's when it was freezing. That's when it was going through the phase change. And so it was not going to go any lower than 0 degrees until all of that water froze, because it's got to get past that freezing point where that liquid is turning to a solid and it's locking those particles in place. Now, you know that it was all solid at 12 degrees Celsius, because at 12.5 degrees Celsius, then it allowed itself to start going below 0. You're still removing energy. In fact, you're removing energy the whole time, but it's not going to go below 0 until all of the energy has been removed in order for it to get below that freezing point. And now it's going backwards and it's melting, and you're probably seeing it drip everywhere, and it's still at 0 degrees because it's melting. It's going back up, and it's going to stay at 0 degrees until all of this is melted, and then it's going to start rising again. But that's just a phase change for you to see, and hopefully clear up any misconceptions. So just graph that on, record that in your data table. And I do want you to draw a graph of this, okay? And think about your independent and your dependent variable. So you're on the bottom, you're controlling the time. You are setting what times you're measuring. So that is your independent variable. Remember, independent, you control. You manipulate. Dependent variable is going to be on the y-axis. And that's going to be your temperature in degrees Celsius. So you got to look at your different temperatures that you use. Let me just draw on the back of this. Let's stick this back in here for a second. All right, so hold on. Remember, you need your labels and you need your units, okay? So we're going to do our time in minutes, and we went to 16 minutes. So you could, if you have graph paper, that's great. If not, just do it neatly on a piece of copy paper. A ruler might help. So I'm gonna do time in minutes. So every half minute, 0.5, 1, 1.5, and so on. And then temperature is gonna be on your y-axis. And we measured that in degrees Celsius. Our highest was 22, our lowest was 4. Remember, this is 0. So you're actually gonna go below 0 to graph. I know that's backwards. But you're going to go actually below 0 to graph your -1 temperature, your -2, -3, -4. You'll graph that down here. So make sure you leave room with your label to be able to do that. And then go up to 22 through here. And it's a line graph because you're showing a relationship. And make sure that you label everything and connect the dots on the graph. We still have ice here, frozen around the bottom of the thermometer. There are going to be some questions for you to answer as well on this, so answer the questions. After you're done, you may have to refer to your notes. Some of the questions may come from the video, may come from some things that we've talked about, but maybe that gives you a better understanding of a phase change. Now, I also want to clarify, this is a physical change. This is not a chemical change. We are not changing what this substance is. It's still H2O. It's still water. It was just liquid when we first put it in there, and now it's ice, solid form here. But we didn't change what it was. It's not a new substance. It's just in a different state of matter. It's still H2O. It's just solid H2O. So that was a physical change. Even mixing the salt in this ice water, that's even a physical change. That is not chemical because it's still salt in here. I could boil all this water off and be left with the salt in the bottom of the beaker because the salt is still there. It's just dissolved, but it's not a new substance. So that is also physical. Remember the difference. Physical, you're not changing the substance. You don't have anything brand new. Chemical, you have a brand new substance. Okay, if you have any questions, email me. Make sure on the Google Doc that you fill in the data table. Make a graph. If you'll take a picture of that graph and see if you can copy and paste that picture into your Google Doc, that would be great. So it's all in one document. And then answer the questions at the end, okay? Hope that you have a great day. I miss all of you.